So this is a reminder, Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and please participate, but please do not share personal information during the session for your own security reasons. At this point, you should have your attendance ticket open. It's in the chat box if you don't have it already. All right, so go ahead, click on that link, enter the password that you see there in the chat box, and make sure you capitalize it correctly and spell it correctly. Remember, passwords only provided in person at live class, right? So you can't get it from the recording. So make sure you're coming to live classes because it's 10% of your grade. So this week we are working all on Unit 5. Unit 5 is kind of a long one. We actually started it last week on Friday. I know I wasn't here on Friday, but I did post a video with the answers to the quiz. So make sure if you haven't done that already, you go back and do that. Smiley faces if you understand. Friday there was an assignment, there was a video. Even though I was out sick, you still need to make sure you go back and do that one. Awesome. Okay, so today though we're going to talk a little bit more about energy. So we're going to talk about potential and kinetic energy. Tomorrow we will have a little lab on how a pendulum works. Okay, so that'll be a quick lab. Wednesday we'll talk about heat energy and movement. And then Thursday is a second lab where we look at a bunch of different materials and see how good they are at containing temperatures. So we're going to design a thermos, all right, using our results from that experiment. And then Friday is an extra credit game day. So remember, last week we had no labs. This week we're making it up with 2 labs. All right, but we will get them done. They will be simple as long as we watch their directions and do it step by step. All right, give me a thumbs up if that makes sense for this week. Okay, I know labs, they're definitely tougher, but we can do them. We've got it in us to do well on them. We just got to be patient. We just got to work hard with the help video. Awesome. Okay, so this week we're talking all about energy. So energy has a very profound effect on our environment. So we're going to talk about how energy changes. We're going to talk about potential versus kinetic energy. And then on Wednesday, we'll also be talking about how heat moves. So that's where we are going today. So today's objective, right, we should be able to Annalise, you should be able to see it now. I just finished grading them. Yeah, so all late lab reports I was able to finish grading today since I was sick last week and didn't get a chance to. Okay, so you should see it now in your grade book. No problem. All right, so today's objective, we should be able to define potential and kinetic energy. We should know the differences between potential and kinetic energy, and then we should be able to provide examples of these 2 types of energy. Okay, super short quiz today. Today's quiz is only 3 questions, so we're going to get that and knock it out of the park. So before we get started though, I do want to review the types of energy. Again, this was talked about in the video I posted on Friday when I was out sick, but I do want to go over it really quickly in case you haven't gotten a chance to look at that video yet. Again, you do need to make sure you do it. All right, it is an assignment, but obviously I know since it's a little bit different than what we normally do, I want to go over it in case you missed it. Okay, so types of energy. There are a bunch of different types of energy. The first type that I'm going to talk about is chemical energy. And chemical energy is energy stored in compounds, right? And they are released through chemical reactions. So for example, how many of you guys know what this is over on the right? Tell me in the chat box, what is this? What little thing is this contraption right here? Yeah, exactly. It's a lighter. Specifically, it's what's called a butane lighter. And in a butane lighter, there's a compound called butane, which you can see right here, C4H10. All right, so that's showing you what that is. It's made up of carbons and hydrogens. And what happens is when it's exposed to oxygen and it gets a little spark, a reaction will happen. And when that reaction happens, it's going to create carbon dioxide and water. Okay, so this is going to break down the energy, all right, and change it into something else, okay? And so that's why it's able to light on fire and have a lot of energy, is because of those chemicals. Smiley faces if that makes sense. This is actually also very similar to how your body uses food, because your food is made up of chemicals. All food is made up of chemicals. Awesome. Okay, now electrical energy. Electrical energy is the flow of charged particles that power electrical devices, and it's also found in lightning. Okay, so smiley faces if you're familiar with electrical energy, right? It powers your lights in your house, it powers your charger to your phone, which is very, very important, right? You get it from your outlets, right? But again, it's also found in nature in lightning, or if you ever, for example, rub your socks on a carpet and then touch somebody else, what happens? What happens? What happens? Yeah, you zap them, you shock them, right? You give them an electric shock. All right, you can even actually sometimes see it, right? Smiley faces if that's ever happened, where you've given someone an electric shock and you were able to actually see it. Right? Yeah, pretty crazy. So it happens in nature all the time. Now, the third type, is that a good example, Annalise? Do you need another example, or are you good on that? All right, I'm going to keep on going. Okay, so the third type of energy that I talked about in the video on Friday was thermal energy or heat energy. These are synonyms. So if you say thermal, that means heat. And this is just the energy due to the speed at which particles are colliding. So this is really important because the speed of particles has to do with their temperature. So if particles are moving faster and faster and faster, that actually makes the material feel hotter and hotter and hotter. Smiley faces if that makes sense. Just like you, right? When you are moving faster, you get hotter. If you just stay still and you don't move at all, you're going to stay cooler. It's the same exact thing with particles. Okay, so that's called thermal or heat energy. Awesome. Now, the next types of energy I talked about were radiant energy or light energy. Again, these are synonyms, radiant and light. And this is just, again, if you think about light, like sunlight or the light from a light bulb or a flashlight, this is a stream of photons that moves in waves. Photons are little packets of light, and they move in a squiggly. Okay, smiley faces if that makes sense. They move in a squiggly pattern. These packets of light that move in a squiggly pattern. Awesome. Okay, now this is not the same thing as heat. It does oftentimes happen with heat, right? So sunlight also happens to heat the earth, but they're not actually the same exact things. Okay, so just keep that in mind. They're not exactly the same thing. They are different types of energy, even though they often come paired together. Now, radiant light also includes things that you can't see. So radio waves, microwaves, infrared waves, ultraviolet rays, X-rays, gamma rays, these are actually all types of radiant or light energy. Okay, it's just that we can see the visible light, and that's the sunlight that allows us to see colors. Smiley faces if that makes sense. Smiley faces if that makes sense. There's a lot of different types of radiant waves, which we'll talk about later. Awesome. Now, mechanical energy, this is the energy that is stored in an object due to its position, which we call potential energy, or it's also the energy due to an object's motion, which is its kinetic energy. Okay, so potential and kinetic energy are both types of mechanical energy. Mechanical just meaning placement or motion. Okay, so if you see right here with a roller coaster, which we're going to talk about a bunch today, depending on where you are on the roller coaster, you have certain amounts of potential energy, and depending on the roller coaster's motion, you have certain types of energy. So we're going to talk about that today. And the last two types are nuclear and sound. So nuclear power is super important because this is what powers the sun and the stars. So what's happening in the sun and the stars is that hydrogens are being combined into helium, and as they're being combined into helium, which happens in the sun, it's very difficult to make that happen on Earth and does not happen naturally on Earth. It does happen naturally in the sun though. But what happens here is this actually causes, because this collision is so massive, it causes us to actually convert some matter into, or some mass into pure energy. And so that's a lot of energy in the sun. Okay, and so that is why the sun is able to give off so much heat and light, is because of this nuclear reaction. Okay, this is also has to do with Einstein. How many of you have ever seen this equation, E equals mc squared? How many of you guys have ever seen that, E equals mc squared? Awesome. So now you can actually tell your friends what this means. So E equals mc squared actually means that mass, when converted into energy, is mass times the speed of light squared, which the speed of light squared is a massive number. So if you take a small amount of mass and you multiply it by this gigantic number from the speed of light squared, that actually makes a really large amount of energy. So we actually can get a ton of energy out of a small amount of mass. Okay, smiley faces if that makes sense. Okay, again, we'll be talking about this a little bit later in the semester. But that is just an intro to it. Awesome. And the last type of energy that we're going to talk about in our course is sound energy. So sound energy is the result of air molecules. So remember that all around you there is matter. Even though you can't see it, all around you there is matter in the form of air. Okay, and so what happens is that when someone's talking to you, those air molecules begin to vibrate, and as they vibrate, they pass along energy to your ear, and as it goes to your ear, you have a little drum in your ear, and that energy from air actually bounces along, and what you're on the drum of your ear, and it actually turns it into into real language, right? It actually translates it into real language. Okay, smiley faces, that makes sense. Pretty crazy to think about that your brain is just very, very clever at figuring out how to translate vibrations into actual language and sound. So Michael, we'll actually talk about a sonic boom a little bit later in class, but a sonic boom does have to do with how fast sound travels. So sound actually doesn't travel very quickly, and so we'll talk about a sonic boom as the result of something traveling faster than sound can keep up with. Awesome, guys. Okay, so let's make sure that this makes sense. All right, grab your whiteboard tools and go ahead and match these on the board, please. All right, what do we know? All right, read carefully. Get your answers up there on the board. I'll give you guys about 40 seconds since I know there's a lot more of these than there usually are. Awesome, about 10 seconds left. Get your answers up there. Being good. 5, 4, 3, 2, and 1. Pausing your tools. I'm going to go ahead and shrink these down so that we can see this a little bit better. Here we go. All right, here we go. So chemical energy. Again, chemical energy is stored in compounds and released by reactions. Remember thinking about the butane lighter. Electrical energy is the flow of charged particles and is also found in lightning. Thermal energy, okay, this one is a little bit more complicated. Remember, thermal energy is actually the energy due to colliding particles. Remember, moving faster, they are hotter. Moving faster, they are hotter. Radiance or light, remember, is a stream of photons. Photons are little packets of light. Mechanical energy is the energy due to position or motion. Nuclear energy is what powers the sun and stars. And sound energy is the vibrations that reach your ears. Okay, give me a thumbs up if you guys feel good about this. Thumbs down if you're still confused about any of these. Again, this is just a brief introduction to these. Excellent. All right, moving on, guys. The last thing I want to review from Friday is the conservation of energy. So remember, energy is neither created nor destroyed. Instead, it just gets changed from one form to another. Okay, so thinking about this, what this means is that the amount of energy in the universe is always the same. Okay, so the amount of energy never gets deleted, it never gets new energy in the universe. Instead, we just change it from one type of energy to another type of energy. So for example, if you think about chemical energy is oftentimes converted into mechanical energy. So for example, a rocket uses fuel being a chemical, and it burns that fuel in order to move the rocket, which is mechanical energy. Okay, give me a smiley face if that makes sense. Fuel is the chemical, it gets burned, and it changes into mechanical energy to move the rocket. Awesome. Now your body is actually doing the same thing right now. Okay, you actually also use chemical energy, and you use chemical energy in the form of food, because again, your food is made of chemicals. And so the chemicals in that food gets burned and it gets turned into energy that your muscles can use to move, which is mechanical. Okay? All right. So that being said, let's go ahead. We've reviewed all that information. We should be pretty set to now talk about potential and kinetic energy a little bit more in depth. Okay? So potential energy which is going to be abbreviated a lot in this class as PE because it's hard to write potential energy 20 times. So potential energy is the energy stored due to where an object is positioned. And the higher up its position is, the more potential energy it has, because this means that it has the potential to fall. Smiley faces if that makes sense. The higher up an object is, the more potential energy it has to fall. Give me a smiley face if that makes sense. Awesome. Thank you, Zoe. Thank you, Emilio. Need more smiley faces, guys. Thank you, Sally, Michael, Sophia. Awesome. Jeremy. Looking good. Thank you, Anthony. Thank you, Sienna. Perfect. Thank you, guys. Okay, so that's a stapler. Don't play. So here's the thing. Once we release that potential energy, the reason it's called potential energy is because it has the potential to now change into kinetic energy. So when we release the potential energy, the object begins to move, and as it moves, it turns into kinetic energy. Yeah, I know, Ariana, you've mentioned that you're not feeling well. So again, if you need to step away, that's totally fine. Just do your best. So for example, if you see here with a dam, all right, so this right here is a dam, and what it's doing is it's holding water on the right side really it's holding water really high up. What are you doing? It's holding water super high up, okay? And as it's being held high up, that means it has a lot of potential energy, okay, because it's got a lot of height. But when it gets released through the dam, its gravity is going to pull that down, and it's going to begin to convert it into kinetic energy, meaning it's going to begin to move. And as it moves through the dam, it's able to generate electricity. Okay, give me a smiley face if that makes sense. Okay, up here on the right side, we've got potential energy, right? So up here we've got potential energy because of the object's height, the water's height. Down here we've got kinetic energy because of the object's motion. Awesome. Okay, this is number 1 in your attendance ticket. Give me a green check when you have that saved. I'm going to go ahead and give you guys 30 seconds to work on that. Green checks, everyone. All right, waiting on a green check from Andrew, Angelina, Annalise, Audrey, Sienna, Charles, Dolly, Haley, Jacob, Jasmine, Jeremy, Johnny, Maya, Melissa. Make sure I get your green checks for number 1. Looking good. I'm moving on. All right, now kinetic energy, right? We just talked about potential energy being because the water is really high up. Kinetic energy, on the other hand, again, is going to be that energy of motion. And this can be anything in motion, right? It can mean an object in motion, right? So someone bowling or someone running or somebody throwing a frisbee. But it could also mean molecules in motion. So for example, when ice melts, its molecules begin to move faster, so they get more kinetic energy. Or when we burn something, those molecules begin to move faster, and so they are molecules in motion, and therefore they have more kinetic energy. Okay, so as we're moving objects that have mass and we're moving them with more and more velocity, they have more and more kinetic energy. Okay, this is number 2 in your notes. Give me a green check when you have that saved. Again, I'm going to go ahead and give you 30 seconds. Work quickly and save your answers. All right, waiting on Andres, Angelina, Annalise, Sienna, Charles, Dolly, Jacob, Jasmine, Melissa, and Zoe O. Make sure I get your green checks for number 2 so I know I'm not leaving anybody behind. All right, let's keep on going. All right, so here's the thing, guys. Now we're going to go ahead and talk about roller coasters, right? At the beginning of class, we talked about our favorite rides, our favorite theme parks. This has to do with today because we're going to talk a lot about roller coasters because roller coasters show potential and kinetic energy really well. So the thing is, potential and kinetic energy can actually exist together because as we move uphill on a roller coaster, remember, motion is what type of energy? Kinetic energy or potential energy? If we're moving, what type of energy is that? Tell me in the chat box. If we are moving, what type of energy is that? Awesome. Yeah, it's going to be kinetic energy. Exactly. So as we move up that hill on a roller coaster, we have kinetic energy. But again, we're getting higher and higher, which means we have more and more possibility of falling. And what type of energy is that? As we get higher and higher, what type of energy is that? As we get into position at the top of the hill. Yes, exactly. It's going to be potential energy. So again, we can see that these are actually happening at the same time because not only is the roller coaster moving, but it's also getting higher and higher. Okay, smiley faces if that makes sense. Kinetic and potential can exist at the same time. They can both be happening at the same time. Okay, so again, potential energy increases with an object's height, which means that at the very top of a roller coaster, you know, the scary point where you're looking down and you're like, oh my gosh, I'm about to die. All right, at the very top of the roller coaster, that is actually where you have the greatest potential energy because you have the greatest energy to fall and turn that into kinetic energy. Okay, smiley faces if that makes sense. Smiley faces if all that makes sense. Going to ask you a few questions about this now. I know, it's a pretty great feeling, in my opinion. I like being at the top of a roller coaster. Awesome. Okay, guys, so let me go ahead. I'm going to give you your polling tools here. Where is the most potential energy or the highest position on this diagram? Take a look at our roller coaster diagram here. Where is the most potential energy? You've got A up here, B down here, C, D, and E. Where's the most potential energy? Use your polling tools. All right, your green checks have turned into polling tools. Grab that tool. Give me an A, B, C, D, or E. All right, looking good. I have about a third of you with answers still waiting. Awesome, half of you. Keep going. What do you guys think the most potential energy? Most potential energy. Awesome. All right, so here we go. Where we have the most potential energy, you guys are correct, is going to be at point A. Point A. And tell me, why do we have the most potential energy there? Someone in the chat box, let's think about this. Why is there the most potential energy at point A? Why did you choose point A? Yes, exactly, because it's going to be the highest point. And right, the higher you go, the more potential you have. Exactly. Okay, now, that being said, where do you guys think is going to be the lowest or the least amount of potential energy then? Where do you think would be the least amount of potential energy? Go ahead, use your polling tools. Polling tools. Polling tools. No worries, guys. I know, it can be a little bit difficult to get used to using the polling tools. Awesome. Let's go, let's go, let's go. Have about half of you now. Keep on working. Looking good. All right, looks like we are a bit split between letter B and letter E. So what I want you guys to think about is which of these is a lower position. Again, if our highest point is the most potential energy, then our lowest point should be the least potential energy. So take a look at B and E, all right, and go ahead and change your answer if you need to. There we go, looking good. All right, looks like we are now choosing B overwhelmingly, and that is going to be correct, right? So point B is going to, it's a little bit hard to see point B. So I remember when I first saw this diagram, I was like, where is point B? I only see A, C, D, and E. All right, so point B, right, this is going to be our lowest point, and therefore it is going to be our least potential energy. Sorry, that should say point and not point. All right, so go ahead, answer these two in number 3. You'll notice that there are 4 questions in number 3, so we will get to the other ones in a few moments, okay? But first answer the potential energy ones, okay? So most should be point A, least potential energy should be point B. Okay, so take a look at the 2 potential energy ones. We will talk about kinetic energy in a moment. Green checks when you have that saved. I'll give you guys 30 seconds. Let's go. All right, looking good. Just waiting on a few more green checks. Thank you, Andreas, Ariana, Brianna, Sienna, Ciara, Edgar, Haley, Jacob, Jasmine, Johnny, Maya, Melissa, and Michael. Make sure I get those green checks, please. Awesome. Again, we will finish the other 2, the ones with the KE, kinetic energy. We'll finish those in a moment. Looking good. All right, so that being said, we talked about going uphill as we go up a roller coaster. Now we're going to talk about going downhill or going down the roller coaster. So again, as we go downhill, a roller coaster is still going to be experiencing both kinetic and potential energy. Okay, so as it travels downhill, because of gravity, it's going to accelerate, which means it gets faster and faster and faster. Okay, where are you at the fastest in a roller coaster? At the top of a hill, the middle of a hill, or a bottom of a hill? Where are you actually going the fastest? Where are you going the fastest? Think about a roller coaster or driving. This is kind of a tricky question. All right, looking good, looking good. Think about this if you are skiing, right? So you're going down a really, really big mountain, all right? Are you going to be going faster at the middle of the mountain or the bottom of the mountain? Right before you reach the bottom of the mountain? What? No, you guys are definitely going faster at the bottom of the mountain. All right? Smiley faces if that makes sense, okay? As you go further and further, remember gravity is pulling you faster and faster. So at the bottom of the hill, you are actually going your very fastest. Okay, smiley faces if that makes sense. You're going your very fastest at the bottom of a hill. I know, it's hard to think about. Awesome. Okay, so here's what's happening. Again, if we're going fastest at the bottom of a hill, that actually means that that's when our kinetic energy is the highest. That's when we have the most velocity, the most motion. So when we reach the bottom of the hill, all of that potential energy gets converted into kinetic energy and it reaches maximum velocity. Okay, so at the very top, we would have, for example, 0 potential energy. Or sorry, we would have 100% potential energy because we are at the very top, the highest we can get. And we would have 0 kinetic energy, right? Because at the very top of a roller coaster, right, remember there's that little moment where you just pause and you're still. Smiley faces if you know what I'm talking about. At the top of a roller coaster, at the tippy top, you're actually not moving for a moment. Yeah, it's the scary part, right? Yeah. So at that point you have 0 kinetic energy because you're not moving. As you go down, okay, you're getting lower, so you're losing some potential energy, right? So you might have 50% potential energy, but you're gaining speed, so you're going to have some more kinetic energy. So now we're at like 50% kinetic energy. Okay. And as we reach the very, very bottom, at the very bottom, you're actually moving the very fastest. So here we have, what, 100% kinetic energy? And now we're at the lowest point, so we no longer have any potential energy. Okay, smiley faces if this diagram makes sense. Okay, smiley faces if this diagram makes sense. Okay, we're converting back and forth between potential and kinetic energy. Awesome. Okay, so let's make sure that this makes sense. All right, grab your polling tools. Oops, sorry, let me try that again. Grab your correct polling tools. Where is the most kinetic energy or speed in this diagram now? Go ahead, take a look at this and tell me where's the most speed going to be. Again, think about when we're skiing. Where are we getting the most speed? The top of a hill, the middle of a hill, or the bottom of the hill? Think about when we're skiing. Where do we get the fastest? Skating down a hill. Skating down a hill. I realize not all of us have been skiing. I've only been skiing once, so that might not be the best analogy. Awesome, looking good, looking good. All right, guys, so looks like we're a little bit torn between B and C. Remember, guys, if we are going back up a hill, are we going to be going faster or slower as we go back up a hill? Tell me in the chat box. Yeah, if we have to go back up a hill, we're definitely going to start going slower. So in this case, this actually means that letter B actually makes the most sense, right? So at point B, we have the most speed. Now, where do we have the least amount of speed? Again, thinking about on a roller coaster, where are you not moving? Where's that one point where you're not moving? Where do we have the least amount of speed? Nope, Kim, you can use the same answers twice. All right, use your polling tools, guys. Where do we have the least amount of speed? Where are we no longer moving? There's that little point where you're not moving. All right, looking good. Now remember, guys, in a roller coaster, the point where you are not moving is when you're at the very, very top of the biggest hill. Okay, so if we think about this here, that would mean that letter A is actually the correct answer. Okay, so point A right here is the correct answer. Smiley faces if that makes sense. Okay, at the very tippy top of a roller coaster, that is where you actually have no speed because you pause for a moment before you fall. These smaller hills, like letter C and letter E, you actually still have some motion. That's how you are able to keep on moving through those hills, right? So you don't actually, you might slow down, but you don't actually stop at these points. Okay, so yes. So, really important for number 3, you actually don't use letter point C, D, or E. Okay, so you will use point A twice and you will use point B twice. Okay, so answer number 3 now for the kinetic energy ones. Most kinetic energy, least kinetic energy. Give me a green check when you have that saved. Go, go, go. All right, just need a few more green checks. Annalise, Anthony, Ariana, Audrey, Charles, Grant, Jasmine, Melissa, Ty, and Zoe O. Make sure I get your green checks. No problem, Annalise. I'll go back to those after I wrap up class, okay? Awesome, looking good. All right, guys, so at this point we should be able to, right, define potential and kinetic energy, understand the differences between them, and provide examples of them. How are we feeling about this? Give me a thumbs up if we feel good about this, thumbs down if we're confused about any of this. Awesome, looking good, looking good. Love it. All right, guys, so at this point you want to make sure that your answers to your attendance ticket are saved, because those answers are also the same answers in your quiz. All right, so here's the link to your quiz. I want you to open up your quiz right now so you can have your attendance ticket on one side, your quiz on the other side. Do your quiz while you look at your attendance ticket that you just did, and then submit them at the same time. Smiley faces if you understand what you need to do. Smiley faces if you understand what you need to do. If you missed something, please hold on until everyone logs out and then I will go back to it. Here you guys go. Here's your last word. Hope you guys have a wonderful day and I will see you later. Bye everyone.